What's going on, guys? Let's see how we can draw the Lewis structure for these two molecules right here and determine whether it's polar or non-polar. So let's begin with the carbon dioxide. So for the carbon dioxide, carbon is going to have 4 valence electron and oxygen is going to have 6. Since we have 2 oxygen, this is going to be 6 times 2, right? And if you calculate this one, this is going to give us 4 plus 12, that's going to be equal to 16, right? And whenever we have the total valence electron, that is multiplication of 8, we can assume that there's no lone pair. Like whenever we have multiplication of 8, and also if we don't have hydrogen on it. So here we don't have hydrogen, so we have 16 valence electron, and therefore we can assume that there's no lone pair. And let's draw the Lewis structure and see how it's going to look like. And carbon has four electrons around it. So if we share each of them with oxygen, so we are going to share 2 electrons with each oxygen, and that's going to create 2 bonds, right? 2 bonds. And oxygen totally has 6 valence electrons, and 2 of them are shared. We only have 4 left. So each oxygen has 4 electrons around it, so it's 2 lone pairs. And if you look at this one, this is a linear structure. So the molecular geometry is going to be linear, and to determine whether it is polar or non-polar, you can use this technique. That is, whenever we have same atoms around the central atom, and if it's symmetric, that's always non-polar. So here we have that kind of pattern right here. This is symmetric, and the atoms around the central atom is same. Both of them are oxygen. So this is a non-polar molecule, right? So let's look at another one, the carbon monoxide. So let's see what is going to happen for carbon monoxide. The total valence electron is going to be 4 plus 6, because carbon has 4 valence electron and oxygen has 6 valence electron. This is going to have 10 valence electron, right? So here we are going to have carbon, oxygen, and around carbon we have 4, and here oxygen. So let's see what happens if we share 1 electron, like 1 bond. This is going to have 3, and this is going to have 5. And if you count the total electrons, this is 2, 4, 5, 7. Not in a octet format, right? Each atom has to have 8 electrons. And if you look at this one has 5, so not in an octet format. What happens if we share 2 electrons? This is going to have 4 plus 4. This will have octet format, but this one only has 2 plus 4, 6. And also if you share 3, still not in octet format, because this is going to have 6 plus 3, that's going to 9, and not in octet format. So here what's going to happen is, so carbon right here, oxygen right here, right? Since we need to have octet format, what's going to happen is oxygen going to share 2 electrons, carbon also going to share 2 of this electron, and when carbon share 2 electrons, 2 of them are left. If carbon share any other electron, this will then never get an octet format. So what's going to happen is, here we have oxygen share 2 electrons already, so 4 electrons are on oxygen now, so 2 lone pairs. So oxygen is going to share 1 more lone pair with this bond, so that's going to create 3 bonds right here, and oxygen only have two electrons around it. And now if you look at this one, this is in total octet format, right? So this one has 8 electrons, and also oxygen has 8 electrons. So now this is in complete octet format, and therefore also, since here these electrons are shared unequally, right? Oxygen is sharing more electron, carbon is sharing fewer electrons. So this is a covalent bond. And to determine whether it is polar or non-polar, we can calculate the electronegativity difference. If you look at the electronegativity for carbon, that's 2.5, and for oxygen 3.5. If you calculate electronegativity difference for both of these molecules, that's going to be greater than 0.5, right? Because it's 1. 3.5 minus 2.5, that's 1. So if it's greater than or equal to 0.5, that is a polar molecule. So this is a polar covalent bond. So that's how we determine these kind of things. I hope you guys find this video helpful. Thanks for watching.